name is Anna 10 Pencil. Welcome back to my channel. We are going through these LeetCode problems and we are on question number 75, sorting colors. And this solution today is going to be in Python. I have not submitted anything for it yet. However, I have read through this problem once, so I'm probably going to read through it one or two more times and find a solution. However, I have done something similar before in a code camp thing I did, which we had to it was like a Dutch national flag thing, so we had to sort it. So anyway, without much further ado or explaining any previous similar experiences, let's jump into number 75, which is called sort colors. So given an array nums with n objects colored red, white, or blue, sort them in place so that the objects of the same color are adjacent with the colors in the order red, white, and blue. Use the integers 0, 1, and 2 to represent the color red, white, and blue, respectively. You must solve this problem using the library's sort function. And then they give us these examples here and the constraints. And the follow-up is, could you come up with a one-pass algorithm using only constant extra space? So I'm hoping I can do that. And this immediately, off the top of my head, is making me think I should do a three-way partitioning algorithm, and that's just kind of where I'm feeling this should go. So let's read through it one more time. So we have an array called nums with n objects colored red, white, or blue. Sort them in place so that the objects of the same color are adjacent with the colors in the order red, white, or blue. So then we use integers 0, 1, 2 to represent the color red, white, and blue, and solve this without using the library's sort function. So I do think that three-way partitioning algorithm is going to probably be our best bet. I do think we are also going to have to utilize pointers in this. So that's kind of where I'm thinking we should start, is defining 3 pointers. So maybe left, current, and right, because we know that there's going to be 3 colors, ergo there's going to be 3 pointers. So let's start with left, current, and right. I don't want to lose that train of thought. But basically what I want to do is set the left pointer points to the boundary of the zeros. The current pointer, then we could iterate through the array, and the right pointer would point to the boundary of 2s. So to say that, I think I'm going to say 0, 0, length, nums, -1. I'm going to do my -1 out here. So we need to move the current pointer either from left to right when we encounter a 0. So, and the 0 in this case is going to be red. So wherever we find red, we have to move it either left or right. So then we need to be able to swap it. So I'm going to say while current is less than or equal to right, then if nums current is equal to 0, then nums left, nums current is equal to nums current nums left. And then we will increment the left. Oops. We will do this. And then do the same thing with the current. So we swap that element with that left pointer and increment both the left and the current. Now, if we encounter a 2, so let's say, for example, let's say elif, if we encounter a 2, then we need to swap the element on the right pointer, but we'll also have to decrement the right pointer. So yeah, because if it's 0, if it's 2, and then if it's 1, it just stays with the current pointer. So we're going to do the same thing here, except I'm going to change this to say right. So instead of this left, we're going to say right. I need to reverse those. Current, right, and then right current. Nailed it. Yeah, because left, yeah, okay, perfect. And then I said we're going to decrement the right. So else we say current. Okay. So that this is just that if we encounter a 1, we just increment the current pointer. This should be a 1-pass solution. So given an array nums with n objects colored in red, white, or blue, sort them in place so that the objects of the same color are adjacent with the colors red, white, and blue. And this would be 0, so that would be red. And then white and blue. Because we want blue to be over on the right. We want this to be over on the left. This might not be a 1-path solution. Maybe it is. You know what? Yeah, it is. Yeah. Because that'll just sort everything. Yeah. Yeah, red, white, or blue. So, red, white, blue, technically. Okay, let's run it and give it a try. Let me fix my typo first. Okay. Okay. All right. Let's go ahead and submit this and see. Ooh, my memory is not very good on this one. But my runtime isn't terrible, so 2 sides of the same coin. I'll revisit this. I did this in about, 10-15 minutes, considering I had to read through this a couple of times, and I read through it beforehand, so I would give it more of like, instead of an 8 and 21, I'd give it more like a 10, 12, 15. Because I did have to set up here a little bit. Okay, so my solution was alright. I definitely could have done better, but this was a 1-pass solution. I probably could optimize it had I not been trying to think of a 1-pass like pattern in my head. And I probably could have made the memory better as a result. Anyway, I'm going to leave this code in my GitHub repo, which is linked down in the video description down below. You guys are more than welcome to fork and clone, make it better, make it worse, have some fun, learn something new, and I will see you guys in the next video. Thank you guys so much for watching. Goodbye.